Hello? Okay. So, unfortunately, my laptop can't work, so we're going to use another laptop. And while he's setting up, I'm going to talk a bit. So, this morning, Desmond, so my name is Anton, by the way, and here's Desmond. Desmond, earlier this morning, gave an introduction on how Kyber network works. And he mainly talked about the contribution side of the liquidity. So, for my talk, for this technical workshop, I'm going to talk about the integration part, or being as a taker. So, yeah. So before I get started, right, since everyone is like really sleepy and this is the afternoon where everyone's kind of like, had a heavy lunch and everyone's kind of like sleepy here. And while Desmond is setting up, can I please ask everyone to just stand? Yeah, please stand. Woo! Yeah, Biddle, come on. Yeah. And let's just do some quick stretches, okay? So let's just stretch. Yeah, touch your head. Touch your shoulder. Touch your knees. Touch your toes. So if you're familiar, there's actually a song here. Head, shoulders, knees and toes. Okay, never mind. Okay, great. So we just needed a stretch. So have a seat. So for those of you who are interested, you can take out your laptop and try out this workshop. But then I can't really demo everything because my laptop isn't working. So I'll just show you the resources of where you can clone the repo and where you can find the documentation, right? So well, Desmond is cloning this. There's actually the repo is called workshop. So it's github.com Kyber network/workshop. And in that workshop repo, you can actually see all the instructions. And what this repo actually does is that you will be, basically all the Kyber smart contracts are in this repo, and you will be deploying it in your local Ganache or your local test RPC. So hopefully you're quite familiar with Ganache or test RPC. And if not, you can just follow through the documentation and play with it yourself. Yeah. Can I go here? So I'll be over here now. Careful. All right. So aside from that, right, aside from the workshop repo, you can actually go to our developer portal. So it's here. It's developer.kyber.network. Oops, wait, how do I do this? Okay, there we go. Can I connect my mouse? So all the information that you would ever need to integrate Kyber, you can find it here in this developer portal. And the more specific part that you need to look into is integrations. So whether you want to integrate directly with the smart contracts or you want to play with the RESTful API, we have an API provided as well. Or you can integrate a widget, right? So let us go through the different methods, right? So first we start out with the RESTful API. We have a guide here on how to use the RESTful API. So for those of you who don't want to directly interact with a smart contract, we provide ways for you to query rates and send out transactions using this API. And if you go to the API section over here, you can find the full documentation of what it provides for you. So like, for example, getting the market, getting the different currencies, etc. So it's all over here. Now, for those of you who are just interested in making a dApp, and let's say you're creating an e-commerce or payments type of dApp, right? Then what might be useful for you is just integrating the widget, where let's just say I want to just receive Ether or DAI as a payment for my platform. You can do this by just integrating our widget. So here we have the different options of what you need to provide. You can just go through this yourself. So just like what is the receiving symbol, token, what is your recipient address, the theme, etc., right? And basically how it looks like is like this. So there's a preview button over here. So this widget is basically something you can embed in any of your dApp. And this allows you to do like a payment type of method, right? Where you allow your user to pay with any token, let's just say. let's say I want to pay with KNC, and it would give me the equivalent conversion from KNC to whatever receiving token that you wanted. And the receiving token that we wanted was ETH. So if you change this, for example, to DAI over here, and then I click preview again, then it will show me the equivalent of the conversion rate from KNC, let's say, to DAI. Yeah. So a good example of an existing application, right, that has integrated this is CoinGecko. So if you guys are familiar with CoinGecko, you can actually see the widget in action, just to see like what you can actually build with the widget. So they actually integrated the swapping widget in this site. Let's just say we look for mana over here. So they actually have this buy and sell button over here, and it calls the widget. Hopefully it loads. Yeah, here we go. So here you can see that by integrating the widget, they can allow their users to easily swap between the many different tokens within their website. So without even having to go to, like, let's say, Kyber swap, right? So if you have this kind of like use case for your application, then you can look into our widget section and integrate this. Now, the more interesting part is actually building kind of like a new DeFi app, right, out of our smart contracts. And that's where this workshop repo comes into play. So I hope you can see this, but let me try to zoom in here. So in this workshop repo, it is a Truffle repo. And here we have all our smart contracts from Kyber. You don't have to be familiar with them, but at least it's there and it's being deployed. And you can write your own smart contracts on top of that. But what's most interesting is that we have here some example code for you to run your different like scripts, some smart contracts, etc. So we made some example code over here. You can use this as a template. So for example, like in Web3, right, if you want to do like just getting the conversion rates or making a trade, we have these examples over here. And basically how this would work, I would try running the console over here and okay, make it larger. Okay, hopefully everyone can see it. Oops. How do I open a new tab? Help. Command T, Command T. Okay, there we go. Sorry, I don't use Mac, I use Linux. Linux forever. Anyway, let me just run Ganache first. Ganache, CLI, I hope this works, because it's not my laptop. Okay. Let me go first to the workshop repo and copy the command. So there's a command here where you can run the repo, right? You can just copy this. We start with a default mnemonic so that it's easy for you to see the deployed contracts, which is over here. It will result to the same addresses if you use the same mnemonic. And of course, a disclaimer, never use this mnemonic anywhere else aside from you know, playing around with the contracts. Oops. Oh. Wait. Sorry. I really am a Mac noob. Need help. Yeah, it doesn't. Wait, did you copy it? I did. Oops. So I can get on C. Command C. Yeah. Okay. Command. Okay. Command G. No. Nope. Doesn't work. Okay. You did. Yeah. Sorry, not my laptop. So. Yeah. Can you copy it again? Yeah. Sometimes you just. Okay. Copy it. Yeah. Ah, finally. Don't go away. I need you. Okay. Now let's run the workshop. Where did you play it? CD workshop. This desktop. Desktop workshop. Okay. You did finish npm install, right? Okay. So Truffle, migrate, network development. So what's actually going to happen here is that it's going to deploy into our local ganache all the Kyber smart contracts and some of the example contracts as well. So you can actually see what's actually happening here, like setting up the different contracts, setting up some mock tokens, etc. This will take quite a while, so maybe you can just wait for it. For any of you who have used Ganache, then this would be quite familiar to see. So let's wait for it to fully deploy. So here we were deploying some mock tokens like Polymath, Mana, Salt, etc. And then we're deploying the different Kyber smart contracts, the different reserves, some example contracts that would call the Kyber smart contracts, setting them up, like setting the different permissions, yeah, and so on and so forth. So basically, you're able to run the entire Kyber contracts in your local machine and do trades, get rates, etc. So this would be perfect for those of you who would want to do local development in your machine and then just test out your smart contracts without having to worry about the delay of testing, let's say, in Ropsten or in Rinkeby. But if you do prefer in working in Rinkeby or Ropsten or any of the test nets out there, if you go to our developer portal, we have the different contracts deployed in all those different test nets. So here, it's finally deployed, and here it shows me the different contract addresses. So for example, the tokens over here, I have some the different admins, etc. And of course, I can run now some of my scripts that would do, for example, an example trade, right? So if you look at the directory, in the examples directory, there's three folders. So there's Solidity, Truffle, and Web3. And what this basically means is that in the Truffle directory, you can run some Truffle scripts. They're basically still Web3 scripts. The main difference is that in the Truffle framework, they automatically expose some artifacts, inbuilt artifacts like the Web3 itself. So you can just run very simple scripts on it. And you can actually run the script by doing truffle exec, and then the name of the script, let's say get expected rate. So what get expected rate script does is that it gets the different conversion rates between ETH to token and token to many different tokens. And this is all within your local machine. So as you can see here with this, I'm getting the different conversion rates between ETH to KNC. And this is, of course, in Wei. So what this means is that 1 ETH would be about 549 KNC, and so on and so forth. And so if we look at the script, right, let's go to Truffle. If you look at the script, it's actually quite simple. So basically in Truffle, most of these artifacts, which are basically the token contracts that have been deployed, are automatically exposed to you, so you can easily call them. And by getting these different conversion rates, right, it's just one smart contract function call. So we have our main Kyber network proxy contract, or basically the main contract that you would be interacting with in Kyber. And all you have to pass in this function is the source token, which is ETH, the destination token, which is KNC. And what this means is that I'm trying to get the conversion rate between ETH to KNC. And then I pass in the quantity, which is around 1 ETH. And afterwards, I get the exchange rate. And that's the same for the other function calls over here. So if I go down here, I'm trying to get the conversion rate between KNC to ETH, and then from KNC to Omisigo, for example. And all I am passing is just 3 arguments, which is KNC, Omisigo, and the quantity. So that's for getting the rates, right? Now, what if I want to do an actual trade? So let's run one of the trade scripts. Oops, trade here. And let's see what happens. So here I have an initial balance on top. I have 1,000 ETH and about 100 or 10 million KNC, I think, and so forth, right? And so I did a ETH to KNC trade, and KNC to Omisigo trade, and KNC to Mana trade. And this is the final balance I have after doing those trades. Now, if we do the trade again, of course, you would see this last initial balance as the initial balance, and you could see more trades happening. So here, like our balance again is updated. We have lesser ETH and more tokens right now. And in this directory, you actually have other simpler function calls that you can use. So for example, if you're just doing a very simple ETH to token swap or token to token swap, then we have some inbuilt functions for this in the smart contract. So for example, let's just take a look at swap ether to token contract. Right? So just the same thing, like declaring stuff. And the more interesting part is here. So again, like the first part where we're just showing the conversion rate, we're doing the same thing. We're getting the conversion rate, right, between a source token and a destination token, and then the source quantity. So I get this rates. There are two rates returned, expected rate and slippage rate. So slippage is basically the difference, right, where the rate could like move within the execution of your swap. So by default, right, in the smart contract, we set this to 3%. So basically, the slippage rate would be 3% more than the expected rate. And we would always recommend that you would use the slippage rate because it means that your contract or your trade execution is kind of guaranteed to execute as compared to the expected rate. Because rates could always change when your transaction is in flight. So again, going back, we have this two rates, which is the expected rate, slippage rate. And then I pass this rate to the swap ether to token function call. And this is where the actual trade happens. So again, I'm passing in the, since I'm doing an ether to token swap, I'm just specifying the destination token and then the conversion rate over here. So I'm using the expected rate in this case. And after this completes, this function call completes, then the trade is executed. So using this swap ether to token function is very simple, but we want something more flexible, right? Where let's say you want to have a smart contract where after doing a trade, you don't want that traded amount back to the user's wallet. You want it to be sent to another contract, let's say. And this is where the trade function helps you on that. And this is the function that has the most flexibility in that sense. So again, going back, we have we are getting first the conversion rate by calling the getExpectedRate function over here. And after getting the rates, we pass them to the trade function, specifying the source token. By the way, in Kyber, because Ether is not a token, we need some way to represent ETH in the smart contract. So we actually use this over here, so 0xEE. So it's just an alias to signify that you're actually, or the user is actually trading with ETH. So again, getting the expected rate. Wait, I'm lost. Oops. Yeah. So here, getting the expected rate, and then doing the trade by passing in the source token, which is ETH, and then the destination, the source amount, which is how much ETH you want to trade, the destination token, and then this is the interesting part, which is the destination address. So in this trade function, I'm specifying the user wallet or the wallet that has called this function. But again, in this trade function, you can specify any address. So you can, for example, forward the trade to another contract. Let's say you're doing like a kind of like an ICO type of contract, right? Where you want the user to pay with any token, but then your contract just wants to receive ETH. So you can actually do a function call through Kyber first, doing the trade, and then forwarding that traded amount to your actual contract. And this is where you can actually do that. Yeah, and then the rate, and then this wallet ID over here, which I won't get into detail right now, but it's more of like applications that have integrated the protocol, and they want to join this kind of like a fee-sharing program. So it's as simple as that. So if you want to play with Kyber, you just have to use two functions, getting the expected rate and then doing the trade. And that's it. You're already using Kyber. And you can embed this functionality in any of your dApps or smart contracts. So think of all the different DeFi applications that are out there. Let's say, like, for example, like Set Protocol, right, which Desmond described earlier, where they do rebalancing on chain. So that's what actually happens when some function is called in the set protocol contracts. They can just call the Kyber contracts, mainly these two functions, getting the conversion rate, and then doing a trade within that one transaction. And in that sense, you can actually do many different transactions in many different function calls in a single transaction. So you can imagine doing an app where the user is sending like 50 ETH, right? And you want to do 5 different trades within that one transaction. So you would have basically 5 different sets of this, getting conversion rate with one token and then doing the trade, and then for the next token, etc. Of course, there are gas cost considerations, but that's kind of like one thing that that kind of like empowers you to do those kind of functionalities. Yeah. So that's mainly the main functionality that you can get from running this workshop. There are actually other examples over here. So, for example. In the examples, aside from the Truffle scripts, we have the Web3 scripts, which is running it like an individual Web3 script. So you're basically declaring Web3, etc., connecting to your provider. It's the same functionality as if you were running the Truffle scripts, and I guess we can do an example of that since we have time. Web3, oops. Okay, so for example, let's run trade. And hopefully it works. Yeah, it's working. Yeah, so this is just a Web3 script that's running. Okay. And aside from those Web3 examples, we have an example for contracts itself. So here I have deployed a contract called trade. Whoops. Wait, go back to the contracts directory. Examples, trade. Okay. So here I have deployed a contract called trade, and this trade is has one function called exec swap. Actually, I think I have another. Yeah, here I have 2 functions called exec swap and exec swap ETH. So let's just look at the second example here, where I'm actually doing a swap between 2 different tokens. So in this function, I'm just taking again the source token, destination token, etc. And from here, of course, if it's a token-to-token trade, then I need to make sure that the user has approved allowance to the smart contract to spend these tokens from his wallet. And this is those parts over here. And again, those 2 main functions is just getting the conversion rate or getting the expected rate, passing in the source token, destination token, and source quantity. And afterwards, after getting this rate, I just call the trade function. And that's it. Your contract has done a trade through Kyber. Now, imagine doing this more than once, right? So we can just copy paste this like maybe 5 times, and actually you're doing 5 different trades within one single transaction. So it's just doing 5 different function calls. So that's basically it. So that's the low-hanging fruit of how you can integrate Kyber. And this is how you can also access liquidity through Kyber. So let's just say you're doing like some kind of like a lending DeFi protocol, or you want to do some a DeFi product like similar to Melonport or Set Protocol, etc. Then if you need to access like some kind of like a different token liquidity, you can do it through Kyber and through this simple way. And if you were there in the initial discussion or presentation of Desmond, then you would know that we are integrated with many different reserves or liquidity providers. So your liquidity needs is facilitated by other reserves like it's coming from, let's say, Uniswap, DutchX, Bancor, Oasis Dex, and other like professional market makers as well. So you through one single interface, which is Kyber, can access liquidity from all these different areas or providers. And you can do that from 1, through the smart contracts, 2, through our, back here to our API, or the third one is just simply integrating a widget. So yeah, that's one. And another part, so this is the integration part, right? But there's also another component of Kyber, which is you wanting to contribute liquidity, right? So for example, you're a token team and you want to have your token available throughout the Kyber ecosystem by creating your own reserve. And so in our developer portal, we have all the description of how you could do this as well. And like described in Desmond's earlier presentation, you can have a reserve type of contract where you have full control of how you do pricing. You can have a model that's quite similar to Uniswap or Bancor, where it's all on-chain, and it does automated market making on-chain. Or you can do like an order book where you post limit orders into the smart contract. So again, we have multiple options of how you can provide liquidity. If you go to kyber.network/hack, our bounties are over here. And one of our bounties actually is to be able to provide a new type of permissionless liquidity contribution type of reserve, right? And another one is also like extending or modifying the widget such that it fits your needs. Maybe something that's not simply just swapping between one to another, but doing something else. You can do those as well. It's part of our bounties. So yeah, that's pretty much it in a high level, I guess. Is there any questions from this demo, I guess, or presentation? And hopefully that means that it's quite simple enough to understand. So again, if you need to go through the documentation, it's just at developer.kyber.network. You can always approach us, me or Desmond. We're always around here if you need any help. And hopefully you can build something quite unique here in this hackathon. So we're actually quite proud with some projects that came out of ETH India that has integrated Kyber. So for example, last year, one of the big winners was the InstaDApp team, right? And they actually created something, I quite forgot the name, but yeah, they've integrated, but they integrated Kyber and then made a product out of it. And they've launched like their own swapping service, which was called EA Swap, I believe. So you can actually create all this many kinds of DeFi applications by integrating Kyber's liquidity protocol. Yeah. So any questions on anything? And I hope I saved time for the presentation. Okay, so that's it. That's all I have. And if you need any help or in the hack or anything, please approach us. And I hope you enjoy building and hacking. Thank you.